Hello, HISD students. My name is Mr. Vivas, and this is the second lesson for Math at Home. Today, we are going to be talking in three different sections. We're going to have sixth grade. We're going to learn about order of operations. Seventh grade is going to learn about problem-solving strategies, and eighth grade is going to learn scientific notation. Let's get started. For our sixth graders, our objective is we will generate equivalent numerical expressions using order of operations, including whole number exponents. The first thing that we want to introduce is the order of operations. Every time that you see the pencil on top, it means that you have to put this in your notes. So let's start. The PEMDAS is a very popular method in order for you guys to remember what operations go first. Remember that first we evaluate the operations inside of parentheses. After we do that, we go to the exponent. The M and D is for multiplication and division, and there is no set of priorities. You just go from left to right. And then the last operations are going to be addition and subtraction. And again, this goes from left to right. Our first problem that we're going to do is the following. We're going to evaluate the following expression on the next slide. And you guys are going to get to see how we use the PEMDAS in order to get our correct answer.
According to our anchor chart, the first part of the expression that we have to look at is inside of the parentheses. So that means that the first thing that I have to start solving is 27 divided by 3 squared. Furthermore, on this expression right here, I have to start, as I see here, with the exponent. So that means that the first thing is I'm going to multiply 3 times 3, which is equal to 9. So that means, I'm going to do it in another color, that this 3 square is now going to be 9. So the final thing that I have to do is divide 27 by 9, which is going to give me the result of 3. So now we just have to go back to our original expression, and the only thing that we have to do is substitute the parentheses with the number 3. And now this is going to be our new expression. Now we look at the exponent. That's going to be the next one. And then I'm going to do a line here so I can organize. And then I'm going to do 10 to the power of 2. That is equal to 10 times 10, which is equal to 100. So now I can substitute the 10 squared by 100. And then remember that when I'm doing a addition or subtraction, the only thing I have to do is go from left to right. So that means that I'm going to do first 35 plus 100, and then I'm going to subtract the number 3. So this one right here is 135. I'm going to subtract 3, and that's going to give me the result of 132. And that, guys, is going to be the answer for this problem.
It's going to be your turn to evaluate the following expression. Make sure that you follow the anchor chart on the top right corner, and let's get started.
Okay, so now let's check for understanding. We are gonna look first, remember, the parentheses. So I'm gonna do it on this side. I'm gonna put a line so I can differentiate, and then I'm gonna do 3 minus 9. So when I evaluate this is gonna be equal to negative 6. So now what I'm going to do, I'm gonna substitute this 3 minus 9, and now I'm gonna add the negative 6. So now that we solve inside of the parentheses, I'm gonna go to the next one, which is the exponent. So now I am going to evaluate 2 to the power of 2. So now 2 to the power of 2 is the same as 2 times 2, and that is equal to 4. So now I'm gonna substitute this, and I'm gonna say negative 4 times negative 6 plus 4. Okay, so now that I did that, the next one will be the multiplication. And we know that the multiplication is happening right here. And I'm gonna multiply negative 4 times negative 6. So remember that 4 times 6 is 24, and since we are multiplying negative numbers, then this is going to become positive. So now I'm going to substitute. This is going to be 24 positive plus 4, and that will be equal to 28. And now guys, this is going to be the answer.
Look at the following problem. We have a store that has a discount of $3 off, and the problem reads like this. Maria wants to buy 3 shirts and 2 pairs of jeans. The cost of each shirt before the discount is $12, and the cost of each pair of jeans is $19 before the discount.
On this specific problem, I can do it two ways. And that's because this ad is not being that specific. So I can say that I'm gonna buy 3 shirts and each one costs $12. And then I'm gonna add 2 pairs of jeans and each one is gonna be 19. So once I do this, I'm gonna do 3 times 12. That's gonna give me 36 plus 2 times 19. That's gonna give me 38. And what I'm gonna do now is I'm gonna add them. So 36 plus 38 is gonna be 74. And once I have that 74, then I can say, well, since the offer is giving me $3 off, I'm going to just deduct or subtract $3, and that should give me $71 for the first scenario. But on the second scenario, I can say that, well, I think that this offer is telling me that they're going to take out $3 for each of the objects. So I can write it as 3 times 12 minus 3 plus 2 times 19 minus 3. In that way, I'm taking out $3 for each of the items that I'm buying. So I'm going to multiply 3 times 12 minus 3 is going to be 9 plus 2 times 19 minus 3 is 16. So now I'm going to do 3 times 9 is 27. And I'm going to add 2 times 16, which is 32. And that's going to give me a total of, that's going to be equal to 59. So out of the same ad, I'm going to have 2 different scenarios based on the understanding of this ad.
We look at both scenarios. Now we're gonna answer the following question. And it reads, why are the amounts Maria pays in scenario A and scenario B different? Please use the following sentence stem in order to answer the questions. time to think about the answer. This is an example of the correct answer for this type of problem. Now we're gonna go to 7th grade content. Objective for the 7th graders is that we will use a problem solving model that incorporates analyzing given information, formulating a plan or strategy, determining a solution, and justifying the solution, and of course, evaluating the problem solving process and how reasonable is the answer that you got. Giving you a strategy that you can use in order to approach all of the problems that you are going to have in 7th grade. And this strategy is called cubes. We're going to go letter by letter so you get familiar with what you have to do in order to use it to your benefit. Start with our letters. So letter C stands for circle the key word. And that just means that you have to find these words that are actions that you have to take in order to solve the problem. The next one is going to be the U, and that's for you to underline any information or any data that you can use in order to get to the correct answer. The next letter is B, and that's going to be box the question. It's just for you to make sure that you are doing everything in accordance to what they are asking you. The next one is to evaluate this strategy. And remember that you have several strategies in order for you to solve one problem. The last one is going to be to actually solve the problem. And this involves to also give a complete sentence answer and make sure that it's a reasonable answer.
Let's see how this works. So I'm going to start with the circle the keyword, and I'm going to start with high. So we have the Mount Everest is 29,000 feet high. A bird is flying and at altitude, that's also uh, the height, 13,000 feet. If the bird gets to the peak of the mountain, well, that's saying that it's getting to those 29,000 feet. What was its change in altitude or the change in height? So let's get to the underline part. We have to underline the key information. One of the informations is this 29,000, very important. That's the height or the peak of the mountain. Then we have the height of the bird's flight, which is at 13,000 feet. Um, we're gonna get to the next part, which is box the question, and of course I'm gonna start with this one right here. What was, that's the question, what was its change in altitude? Now I'm gonna evaluate this strategy. So if I am thinking on getting the change, this means that I had to subtract. So I can already say that I have a strategy in mind, so I can just go ahead and subtract the 29,000 minus the 13,000, and that will give me a change in altitude. Then if I go further, this is going to be 16,000, and that's going to be the change in altitude. And now it says solve the problem. Remember that um, solving the problem is getting an answer in a complete sentence and making sure that it makes sense. So I can say that the change in altitude was 16,000 feet.
We're going to get familiar with just some of the ways or strategies that you can use to solve problems. The first one is to make a table or a chart. And this is just to see if you can find any type of help. You can use this table or chart to see the problem as a whole. You can also draw a picture or a diagram. If you are more of a visual student, maybe by drawing a picture, you can organize the information better. Another way is to find patterns or use a rule. And remember, these strategies, you can use them together. So if you want to make a table, so then you can see a pattern, that's also a very good way to find the correct strategy. Check for relevant or irrelevant information. And I think the cube strategy that we introduced is very useful for you guys to realize which information is needed and which one is not. Make an organized list is another way that you can find the correct strategy. And of course, work backwards is another way that you can do this.
I'm gonna start using cubes, and I'm gonna start with circling the keyword. So I'm gonna say spend, each video costs $11, maximum number of games that he can buy. Then I'm gonna underline the key information so I know that he has $100 and each video game is $11. The next one will be to actually box the question. So it's gonna be what is the maximum number of video games that Carlos can buy. And now to evaluate and to solve the problem, I'm gonna use this problem solving math. So what do I know? I know that Carlos has $100 and that the video games each cost 11. And what is the question asking? I have to find the max amount he can buy. Okay. The strategy I'm gonna use to solve the problem is to find a pattern. So what I'm going to do, I'm gonna try to draw. Let's say that this is the video game, and this cost me $11. Only one video game. If I have two video games, then 11 plus 11 will be 22. And then if I have three video games, 11 plus 22 will be 33. So the pattern that I see is that if I multiply 11 times the number of video games, I'm going to be able to see the total cost. So I know that if I go 11 times 9, then that will be 99, and that will be the max number of video games that I can buy. So that means that my solution has to be 9 video games. So then I'm gonna use my solution box in order to give a complete answer. So the max number of video games is 9. And that will be the way to use the problem solving math and the cube strategy in order to have an organized way to approach a specific problem.
Now we're going to start our 8th grade section, and the objective for today is that we will convert between a standard decimal notation and scientific notation. We are going to start with the word scientific notation. And this is just a method that we are going to teach you on how to express numbers that are very, very big or that are too small. We're going to have certain rules that we're going to introduce to you. Just think about, let's say, the distance between the Earth and the Sun. is actually about 150 million kilometers. So scientific notation is a method that can make this number expressible in a shorter way. Or another example is the width of a single human hair. It's actually 180 micrometers, which is 0.007086661 inches. So again, scientific notation will be a method that will make this number easier to express. Now let's look at the following examples and let's use scientific notation so we can express the weight of different transportations.
The weight of the car is 4,009 pounds. So we said that the scientific notation uses a number that is equal to 1 or greater and less than 10. So of course I cannot use 4,009. So in order for us to make it a number between 1 and 10, I have to move my decimal. And remember that on a whole number, the decimal point is always at the end. So I'm gonna draw it over here, and that's our invisible decimal point. If I move it once, right, it's gonna become 400.9. So as you can see, I have to move it to the left as many times until I get a number between 1 and 10. So I'm gonna go again one more time, and this makes it 40.09. That still does not work. I'm gonna move it one more time, and now I have 4.009. That's my first number between 1 and 10. So that's the number that I want. So I'm gonna write it over here. It's gonna be 4.009, and now I have to multiply times a product of 10, and it says that the exponent has to be equal to how many places I move my decimal. So in this case I move it once, two, and three times. So that means that my exponent on the number 10 is gonna be 3. And that's how I change a number that is in a standard form to a scientific notation form. So now for the weight of the bus, um, I have now a scientific notation number. So I have to change it to a standard notation. So basically we're gonna do the work backwards from our previous example. So I'm going to write the decimal form 3.4, and then I'm gonna use this exponent right here that's telling me how many spaces I have to move the decimal point. Since it's a positive, it has to go to the right. So that means that I have to move this decimal point 4 times. So I'm gonna move it once, that's one. Then I'm gonna move it twice. I'm gonna move it 3 times, and lastly, I'm gonna move it 4 times. That means that my new decimal point is gonna be right here, and then all these spaces that I don't have any numbers in, I have to fill them out with zeros. So I have 1 0, 2 zeros, 3 zeros. So I can say that the standard notation of this scientific notation number is going to be 3, 4, and 3 zeros, which means that this is 34,000 pounds. So the weight of the bus is 34,000 pounds. Okay, now you had your chance to apply what you just learned, and I'm just gonna give you the answer for this one. So we have 175,000, and I have to convert it to scientific notation. I remember that the invisible decimal point is gonna be on the far right, and then I have to start moving to the left until I have a number between 1 and 10. So I'm gonna move it all these spaces until I come up with this decimal. So now what I'm going to do is I'm gonna write the decimal 1.75, and then I'm gonna multiply times a number, and the exponent is gonna be equal to the number of spaces that I move. So that means that I move 1, 2, 3, 4, and 5. So my scientific notation is gonna be 1.75 times 10 to the power of 5. Okay, so I have the standard notation for the radius of a gold atom, and I am going to need to start um, counting the spaces in between this number right here, and remember, a number between 1 and 10. So what I'm gonna start doing is I can see that the decimal point is right here, and I'm gonna start moving spaces until I find the first number that is equal to 1 or greater than 1 but less than 10. So I'm gonna go one space, I'm gonna go for each space until I get to my first number that is between 1 and 10, and that will be this one right here. So just the same as the with the very large numbers, these tiny numbers are going to be written the same way. So I'm going to write it as 1.66 multiplied times 10, and now the exponent is going to be equal to the number of spaces: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that means that it's going to be 10 spaces that I'm going to put here. But remember, since this number as the standard notation is less than 1, that means that my exponent has to be a negative. So now that we have a scientific notation and we are trying to make it a standard form, I need to use the exponent in order to know how many spaces I have to move. And remember that the negative sign just means that instead of moving to the right, you're gonna be moving to the left. So let's start. I'm gonna have the number 1.72, and I'm gonna move this decimal 10 times to the left. So I'm gonna go start 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this is going to be my new decimal point. And remember that for each of these spaces that I draw, I just have to fill them up with zeros. So I'm going to have all of these as part of my new standard form for this number, and this is gonna be the standard form of the scientific notation for the radius of a silver atom. Now that you had your chance to check for understanding, I'm just going to give you the answer for the last problem. So on this one, remember we had to draw the decimal form and then start moving the decimal according to our exponent. If it's a negative, I have to move to the left and I have to move it 10 times. So I'm going to start 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then my new point is going to be right here. And remember, you just had to fill out the spaces with zeros. That means that this should have been your answer for the radius of a mercury atom.
So we got to the end of our second lesson of math at home. Make sure that if you need any extra resources, that you visit HISD at home for anything that you need help with, and stay tuned for next week's lesson, and I'll see you around.